Let's see. Zeeman effect. First, Zeeman effect. Zeeman effect is defined as the splitting of a spectral line into a number of component line with the application of magnetic field. It's called Zeeman effect. And in this, we can say that there is we can say that spectral line is divided into a number of components with the help of magnetic field. And this theory is given by Peter Zeeman in 1896. Here we have experimental arrangement of or experimental setup of Zeeman effect. For this we have S, that is source of light. S is the uh, source of light of light ray of sodium lamp. A and B are the two pole piece, and the modified light may be observed by high resolving instrument. They are resolving instrument and they analyze by nickel prism. This is nickel prism. Nickel prism is used in this instrument, and we can observe either parallelly or we can observe in parallel view also and perpendicular view also. When we observe in parallel view, the original line will not be seen, but when we observe in perpendicular view, then original line, we can see the original line. And there are two types of Zeeman effect. They are anomalous Zeeman effect and another is normal Zeeman effect. Normal Zeeman effect is defined as the splitting of a spectral line into three components, and in parallel view there are only two components. And here in normal Zeeman effect, we can see we will apply the strong magnetic field, but in an anomalous Zeeman effect we have to apply weak external magnetic field. And anomalous Zeeman effect, there is the splitting of spectral line of component into number of component, that is more than 3 component in the presence of weak external magnetic field. But in normal Zeeman effect there is strong magnetic field and the number of components are only 3. Here is the definition of normal Zeeman effect: the phenomenon of splitting of a spectral line into three component light, including original line, and original line is absent in parallel view. Here we have the figure. In the parallel view, original line is absent, but in perpendicular view the original line is present. This original line in parallel view we can see these lines, but in perpendicular view we will see the original line, that is B0. This is the B0 line. And here is the sodium doublet having wavelength 5890 Armstrong, and another wavelength having 5896 Armstrong. D1 have this, and it is split off into 1 2 3 4 5 6 component, because it has 5896 Armstrong wavelength. But here the wavelength having 5890 Armstrong, there are only 4. It is split into only 4 lines, and here weak magnetic field is applied. Another normal Zeeman effect. Normal Zeeman effect is called normal as it can be explained from classical theory, which is given by Lorentz. But anomalous Zeeman effect is called anomalous because it cannot be explained from classical theory. Anomalous Zeeman effect can be explained on the basis of quantum theory. Here is the classical theory of normal Zeeman effect, which is given by Lorentz. First of all, let us consider an electron. Let us consider an electron of mass m and charge E. Charge E moving in the circular path, moving in this circular path of radius r, it has radius r with a uniform velocity v. This with a uniform velocity v, the necessary centripetal force required for the motion of electron is given by mv square by r, and here v is equal to omega r. Then we will replace v with omega r, then omega m r square omega square by r. Then we will get Fc is equal to m r omega square. When the external magnetic field is applied, then the additional force, who will get this force when external magnetic field is applied, then which is given by Fb is equal to external magnetic force is equal to EVV sin theta. But here sin 90, here is sin 90, so into 1 we are replacing sin 90 into 1, so you will get EVB only. VB is equal to FV is equal to EVV only, because sin here is sin 90 angle. Then let dw be the change in angular velocity. dw be the change in angular velocity of electron due to applied magnetic field B. Then Fc is equal to m omega square r, and Fb is equal to EVV. But in the equilibrium condition, Fc plus minus Vv is equal to mr omega plus d omega whole square. We are replacing this value here and this here, omega square plus, we are using formula here, and then we will calculate this, and here omega square dw omega d omega square it's approximately is equal to 0, so we will put here 0, we will replace it, and then we will get omega square is cut, then we will get plus EVB 2mr omega dw, and we are replacing rw with b here, 2m bw b omega. and then B will be cut, cancel out, and then we will get EB 2m dW, and W is equal to 2 pi V. W is equal to 2 pi V, then dW is equal to 2 pi dV. 2 pi dV. dW is equal to 2 pi dV. We are differentiating here. Then from equation 7 and 6, we will get this value. We are replacing here dW with this value. Then we will get 4 pi m dV. dV is equal to plus minus EV by 4 pi m. As B is equal to C by lambda. As B, we know that B is equal to C by lambda. Then differentiating both sides. Then differentiating, dV is equal to minus C lambda square, C lambda square d lambda. Here we have differentiate here. Then we will get this as dV is equal to C is constant and 1 by lambda means lambda power d lambda. Then we get dV and C means this formula, and x power n minus and x power n minus 1 means minus 1 will become here, then lambda, then minus 1 that is minus 1 by lambda square. We have written here. Got it? And from this equation and this equation, we will get this value d lambda. And d lambda represents the change in wavelength called Zeeman shift of spectral line. That is called d lambda represents the change in wavelength called Zeeman shift of spectral line. That's it.